Hey everyone, welcome to This Explainer. Today, we're diving into part 204 of Eng's Haskell programming notes to uncover a really sneaky hidden memory trap and, of course, its elegant solution. You know, as functional programmers, we're constantly refactoring code, right? We want it faster, safer, just more efficient. But sometimes, the everyday tools we reach for by default, they're actually hiding some pretty serious dangers. So, ask yourself, is your Haskell code secretly leaking memory? Think about the functions you write literally every day. You've got this incredibly concise, seemingly harmless code. It passes all your initial tests perfectly, high fives all around. But what if I told you that beneath that beautiful, clean syntax, there's a ticking time bomb for massive memory consumption just waiting to go off? That's exactly the scenario Aang ran into. And honestly, it is way too easy to fall into this trap. All right, let's get right into it. Section 1, the Haskell memory trap. In Section 2, the trouble with foldl, which is the silent culprit in Aang's code. Okay, so to understand why a standard everyday function like foldl can be such a huge problem, especially when Aang was using it to process really large strings and map over character replacements, we have to talk about the thunk chain. In Haskell, we all know it famously uses lazy evaluation, meaning computations aren't actually performed until their results are absolutely needed. Instead, the program creates a thunk. Think of it as basically an IOU, a promise to do the work later. But when you use foldl over a huge dataset, like a massive string, these thunks, they just start stacking up. You end up with this massive buildup of delayed computations. It creates this invisible, towering chain of promises before even a single item is actually evaluated. So, what actually happens when that chain gets too long? Well, it leads directly to crippling memory consumption. Your program is suddenly forced to hold all of those deferred instructions in memory at the exact same time. Eventually, if the list is long enough, like say you're processing a truly massive text file, the system literally just can't handle the overhead. And bam, you're hit with the dreaded Stack Overflow. The program crashes, and it all traces back to that one seemingly innocent write fold. Which brings us to our next section. Section 3, the strict solution. Using foldl prime, a tiny but powerful change. So, take a look at the surgical, literally one character difference that solves this whole mess. We have the old syntax using foldr compared to the new syntax using foldl prime. Notice we aren't completely rewriting the logic here at all. We're simply swapping foldr for foldl prime, specifically with that little prime symbol, the apostrophe, tacked on to the end. It's this incredibly subtle change to the syntax, but functionally, it completely alters how the entire program processes your data. Now, you might be wondering, why does that one little character matter so much? Well, the prime character, that little tick mark next to foldl, it forces what we call strict evaluation. So instead of building up that massive, precarious chain of promises we just talked about, foldl prime destroys the thunk chain before it can even form. It does this by evaluating the accumulator strictly and immediately at every single step of the fold. It just does the math, right then and there. And as Aang noted in the source material, this strict evaluation gives us 3 absolute game-changing benefits. Because the accumulator is evaluated step by step, memory usage becomes flat. It doesn't spike wildly as some hidden chain builds up. Because of that, it becomes predictable. You know exactly how your program's going to behave, totally regardless of the input string size. And most importantly, it becomes safe. That looming threat of a sudden stack overflow taking down your whole application, completely neutralized. Moving on to Section 4, the readability trade-off, a true developer dilemma. Right, so here's the catch. If passing complex Lambda functions into a dense one-line fold prime is just a bit too hard to parse for your team, Aang offers an alternative approach. You can create a local recursive loop helper function. This is something that commonly uses the loop and go idiom in Haskell. Now, this approach does abandon the ultimate brevity of the built-in fold functions, but it does it specifically in order to prioritize human comprehension. Let's actually deconstruct the logic of that go loop step by step. Step 1, you pass in the current state, which basically acts as your accumulator. Step 2, inside the loop, using a simple let binding, you perform your text replacements and update that state. And step 3, you recurse. You call the go function again with the newly updated state and the rest of the list. It accomplishes the exact same strict evaluation as foldl prime, preventing the memory leak, but it lays the steps out super clearly, line by line. Which leads us to our final section, writing safer Haskell code through intentional choices. So the really crucial point here is this core trade-off, which is perfectly summarized by a quote from Aang. They write, The code is way more verbose, but at the price of improved readability. And, this validates a pretty profound truth in programming. The mechanically smartest or most concise code, like our clever little one-line foldl prime fix, isn't always the most maintainable code. Sometimes taking the extra time to write out a multi-line recursive loop is actually the better choice, simply because it clearly communicates your intents to your fellow developers. Or, let's be real, to yourself 6 months down the line when you've completely forgotten how it works.
So, I'll leave you with this. Where do you draw the line between concise code and readable code in your own projects? Do you prefer the elegant, strict one-liner that completely prevents the thunk chain, or do you lean towards the verbose, step-by-step recursive loop that literally any developer can read at a glance? Balancing performance, memory safety, and maintainability, it really is an art form. Definitely keep that in mind the next time you find yourself reaching for a standard fold function. Thanks so much for joining me for this explainer, and keep coding safely.